What's going on? Welcome back to All This Math. And for this lesson, this is Professor Parker, by the way. You probably already knew that. For this lesson, we're doing some quadratic function applications. All right. So these are like the word problems that everybody hates. Right. This is an example of the word problems. So I want to like explain this word problem to you, break it down, make it seem simple. So when you see problems like this, you won't be intimidated by them, because they're really not that bad if you know how to do them. So I'm going to show you how to do them. Now, there's a long word problem that you can see I did not write on the board. It is in the description under the video, though. So you'll be able to read it word for word in the description under the video. I do have the equation that we're going to use, or the quadratic function we're going to use. And also, this is a diagram of what's taking place within the word problem. So the word problem reads this way. It says a rocket. All right, so try to visualize. Whenever you encounter word problems, try to visualize them in real time. Like imagine a rocket that blasts off from somewhere in Florida. Rockets, that blast off by NASA. Usually they get, I don't know, what is it, like Cape Canaveral or wherever they blast off from. But try to visualize that, right? I know everybody likes to wear like NASA t-shirts, NASA hoodies, NASA sweatshirts. So when you see a problem like this involving rockets, thinking NASA, you might have like some NASA apparel or whatever, you know what I mean? So a rocket is launched from a tower. So we got our tower, here's the ground, right? I got my little rough sketch right here. Here's the ground, this is the rocket. All right, imagine the rocket was right here and it blasts off right here. So I got my arrow showing what's happening, right? It's not gonna go up forever. At some point, it's gonna hit a high point and then it's gonna drop off, right? So a rocket is launched from a tower. This the tower is launched. The height of the rocket, y, the variable y, which is that right there, in feet, which is measured in feet, is related to the time after the launch, x. So wherever you see an x at, just know that that's the time. So the height is y and the time is x, right? In seconds. So the height is y measured in feet. The time is x measured in seconds, not minutes, not hours, not days, not weeks, not none of that, in seconds. By the given equation. This is the given equation, right? So this is the situation. At any point, like this is why equations are helpful and why we use word problems, so we can figure things out. So based on this equation that we're given, if you want to find the height of this rocket at any point, you would do -16 times the amount of time that has went by after its launch squared plus 174 times the amount of time that's went by after its launch plus 78. And that number will be the height of the rocket at that point in time. All right. Now this works for any, like any point, any amount of time. You can just plug in for X and figure out the height of the rocket. Or if you wanted to know the amount of time that has went by after the rocket is a certain height, you just plug in a certain number for the height, which is y, and then you solve for x. You know what I'm saying? So you just have to solve for x. And this is what we use word problems for. This is what we use equations and formulas for, right? To figure things out, to solve problems. That's what math is for, to solve problems. A lot of us are programmed that math is too hard, math is too difficult, I can't do it, right? You know what? That's programming, so that you won't try to solve problems. Because what happens to you if you can't solve problems? If you can't solve problems, then the people and the entities and the groups that benefit from you having those problems will continue to benefit, right? Well, they will continue to benefit as long as you have problems and you don't have the skill that is needed to solve the problem. And you might say to yourself, well, I'm not about to be no, aerospace engineer. I ain't trying to work for NASA. So why is this problem relevant to me? I'm going to tell you why. Because the same method in which you can solve a problem like this, you can solve another type of problem in your life that is relevant to you. So it's not about, don't get caught up in the rockets and all that. Don't get caught up in all that. Get caught up in the method. How do you go through a systemic way of solving a problem? Because if you could solve a problem in math class, you could solve a problem anywhere. There's similar steps that are involved in solving problems. So keep that in mind. That's why, again, don't fall for the programming. We program to think we can't do math. We program to think we're going to be bad at math. We program to think math is too hard. It's because they don't want you to be able to solve problems. People benefit from you having those problems and you maintaining those problems and not being able to solve them. Because once you solve your problem, then they can't exploit you no more. So it gets deep. It's deeper than It's deeper than your math class. It's deeper than your Algebra 2 class. It's deeper than all that. So keep that in mind, for real. All right, but anyway, let's get back to this. So using this equation, find out the time, x. So we know we're looking for x because it says the time at which the rocket will reach its max, the highest point. Now, based on my drawing, the highest point is going to be right here. See how it goes up? It's like a basketball. Like if you play basketball, you play football, right? That's an example of what we call a trajectory. You can measure, like there are formulas you can use to improve your jump shot, right? There are formulas you can use to improve. If you play quarterback, there are formulas you can use to improve, your passing accuracy, right? Using this, because this is what happens, when you shoot a basketball, all right? Same thing if you throw a baseball. All of this, it's the same concepts, all right? Find out the time, so find out x, at which the rocket will reach its max to the nearest hundredth of a second, to the nearest hundredth of a second. All right, so that means we got to round them off, right? All right, now, there's a piece of information that you got to know. It says when the rocket will reach its max. Now, this is a parabola. Put that in your notes. This is a parabola, right? You can tell how it's shaped. And also when you have a quadratic formula, not a quadratic formula, a quadratic equation, meaning the biggest exponent is a 2, that means the picture of it or the graph of it is going to look like this. It's going to be a parabola. It could be opening downward, and sometimes the parabolas are flipped and they open upward, right? This one is opening downward. And we know that because the lead coefficient A, which in this case is -16, is a negative number. Whenever A is a negative number, the parabola is going to open down. When A is positive, the parabola is going to open up. So at any rate, the max is also called the vertex. That's called the vertex. So when you see a problem like this and asking you about the max value or the maximum height or at what time will it be at its maximum height, what it's really telling you, and this is one of the cheat codes, and this is why you gotta practice these problems. And if nobody ever told you this, then this problem will seem hard. But here I am, I'm telling you this. When you're looking for the max, all you're looking for is the vertex. So go ahead, write that down in your notes. When you're looking for the max, the maximum, or the highest point, you're looking for the vertex, because that's what the vertex is. But what you're looking for, so the vertex is a point. And a point, we're not doing nothing three-dimensional, no 3D right here. We're doing two-dimensional. So it's got an X value and a Y value. So the max, or the vertex, got an X value and a Y value. The X value is how, the horizontal location of the point, right? The Y value is the vertical location of the point. So that's what we're looking for, right? Actually, no, I'm tripping. We're looking for X because we're trying to find out the time. The problem says, find out the time at which the rocket will reach its max. So find out the time at which Y will be the vertex, right? So we want to find the time though. The time is the X value. The time is the X value because in the problem, it tells us the height of the rocket, Y in feet, is related to the time after launch, X. So it tells us that X represents the time. So that's one of the things you got to pick up on whenever you read a word problem. You got to know what the variables represent, what the variables stand for. That's what you got to know. All right. So now there's a formula that we use to find the vertex. Now the formula we use, I should say this. There's a formula we use to find the X value of the vertex. All right. And then once you find that number, then if you wanted to find the Y value of the vertex, all you would do is just plug in or substitute that number into the equation and then do the math and then figure out what Y is at that X value. But in this problem, all we care about is the X value. We don't care about the Y value. All right. So the X value is this, -b over 2a. That's the formula for the X value of the vertex. So now you should be saying, all right, well, what number represents B? What number represents A? That should be your question. Now, B is always the coefficient of the X term, or the X to the first power term. So in this case, B is 174. A is always the coefficient of your X squared term, right? In a quadratic equation. So X squared, your coefficient is -16. So those are my two numbers. So all I do now is I plug them two numbers in and just do the math, make it do what it do. I do the math, and then I'm gonna know what X is. So now I got negative 174 divided by 2 times negative 16. And then I got negative 174 divided by, don't forget, positive times a negative equals a negative. So this is negative 32. And I already did this problem, so I'm about to go back to my notes. So negative 174 divided by negative 32 is positive, because a negative divided by negative is a positive, and time is positive, right? Time should be positive. 5.44 seconds. Now, why did I round it to 5.4 seconds? Because the instructions say to round it to the nearest hundredth of a second. And this is the tenths place, and this is the hundredths place. This is the ones place, then there's your decimal point, this is the tenths place, this is the hundredths place. So that means that, let me see, let's go back here. Find out the time at which the rocket will reach its max. So at the 5.44 seconds, this rocket will be at its max, its highest point. After that, it's all downhill from there. So at the 5.44 seconds, it's going back down because it's going to reach the max at 5.44 seconds. All right? So, and that's how you do that. That's it. It ain't that deep, right? But it would seem that deep if nobody taught you how to do it. So now I just taught you how to do it. So now it's not going to be that deep. From now on, it's not that deep no more. When you see a problem involving a rocket, it could be a lot of other things. Like, I'm trying to think of some other examples. They escape me right now. But anything involving a trajectory and you're given an equation, just understand that X usually represents time. Y usually represents the height of the object. If something got thrown, something got kicked, something launches off in the air like a rocket, or airplane, or whatever, right? Y is usually the height, X is the time. Y is the height, X is the time. Plug the numbers in. But you really gotta just like read the word problem and understand what you're being asked to do and just take it from there, you know? So now I've shown you how to answer a problem like this. Now your job is to go practice. Now you should get practice problems either from your teacher, your professor, your textbook, or go online, do your own personal research and find some practice problems. Find some practice problems and practice, because if you don't practice, then, you know, this video ain't gonna help you that much, because, you know, you're gonna forget what I did. Like, I just showed you that I know how to do it. And you're supposed to use this as a guide for you to do the problems on your own. That's what's really supposed to happen. But you gotta go practice, all right? So go get some practice. I'll catch you in the next video. Peace.